Hi, welcome everybody. I'm just happy to see you all joining us today again. Happy to have a new episode of our AI meetup here, and also happy to welcome Divya to our evening.
Hi everyone. I
Fantastic.
cannot hear you guys, but I know you guys are there.
Oh, you might hear them as well. Let's wait.
Oh, good.
Yeah. So I'm actually here for managing all the things and even allow people to speak up at some point. Some administrative tasks. Um, I7 did right. You start work on IT and bridge engineering. Justin, sorry, you just interrupted me. That was fine. I love that. Yeah, I will tell you a little bit in a second. So just an organizational thing before we start. Look at the navigation bar, unless you haven't been familiar with that already. You have that Q and A button icon somewhere. In case you have a question during a presentation, don't hesitate. There's actually no dumb question, please. So no silly questions. It's all fine, and I'm happy about anyone who's just curious and would like to hear and learn more about what we hear from Divya today. Also, I'm going to start a poll in a second, which I usually do. So this is what you just probably see at the moment on your screen. This helps us a little bit to better understand what kind of background you have, which is interesting. It helps us a little bit to focus and not to be too speedy in some things if you might have questions, and just beginning with understanding what IoT is and how you can use that in your business, in your daily work. So before I'm going to start to talk a little bit with Divya, because Justin just mentioned it, I want to just show you something from the past, and this was a story why I was actually interested in IoT again. This is one of the past shows he had. It was actually based on, look, this is really far behind us, yeah? September 2018, yeah. And the funny point was at that time we really met in person, yes. So we're all online now, we're global now, that's fine, so I'm happy about that. The funny thing at that time was we actually had some folks from London University who were working in a project about that kind of bridge which was built at that time in Amsterdam. So a startup was working on building a stainless steel bridge in Amsterdam with the aim to do that with robots, so it was not with people. We use artificial intelligence for the construction, for the statics, and so on. And the aesthetics, I think it was something like those famous architects in Barcelona. Yeah, we just stand in front of it and say, "Wow, that looks cool. That looks awesome." And when I was looking and was listening to those guys, we were actually talking about what their job was to do research on people walking across the bridge and using sensors to measure the impact on what they're doing on the bridge itself. So that was my first part when I just get to know IoT and the impact of IoT and model building and what kind of problems might occur. So this was just that time. So thanks for having me just talk about that a little bit. Divya, but no, I would like to talk to you, of course, a little bit. So
Sure.
let's see. The poll is completed. I think we got most of the responses.
hmm
So for you, maybe also interesting, looking at what kind. I think I can share the results. Can you see
hmm
them?
Yeah.
Yeah. So you can see the results. Data
hmm
scientists. See, software engineers, most people are actually software engineers. But we also have people, project management, consulting, academia, and
hmm
other. So there's a good split between people really working in
Yeah.
the field, obviously, and just people curious and to listening to what you have to say. I think that's a good point.
hmm
Also, we have a lot of people just novice to the field of
hmm
IoT, which is interesting. I think you probably have a lot to share about telling us what it really is.
Yeah.
In aspects, right?
Yeah, that's true.
Okay, cool. Advanced 32% up. That's awesome. I think we get really an idea.
Yeah.
Thanks again for just taking part in the poll. Divya, what are you doing on a daily basis?
IoT.
IoT, cool.
Yes.
What does it mean?
So I'm working mostly on creating different architecture solutions for different customers. So I'm helping them create their solution using different solutions that SAS has. So I'm working as a solutions architect in SAS, and I'm part of IoT Global Division. So I'm responsible to understand what are the problems that the industry's different customers are having or partners are having, and then create an architecture solution using the analytics solutions that SAS has. So majorly I'm working in with ESP, which is event stream processing. So basically it allows you to do real-time processing using this solution, and also at the same time how we can move this whole traditional way of running servers to Kubernetes clusters and to cloud platforms. So it's a good switch from on-prem to cloud, and very many people and many customers are hesitant to moving to cloud, and sometimes it doesn't also fit their needs to move there, and they are still good with the on-prem, and it makes more sense to be on the on-prem. So I'm working on the solutions that fits in for the cloud as well and for the on-prem as well, and everything is now container based, so I'm spending most of the time designing and helping them do the solution, create the solution in their environment, from the test to production.
From your background, it would be interesting. So IoT is obviously something which is really fascinating for you. What's your background? Are you software engineer, data scientist? What are you?
I'm a soft solutions architect, but before that, I was working and doing my PhD, and I was researching on cloud computing area, and there I was working mostly on the BFT protocols, that's Byzantine fault tolerant protocols. So I was determining why the outages happen and what are the reasons behind it, and how we can have different protocols, like especially in the Byzantine faults, how we can prevent from them from happening, and what are the different protocols that we can use. So now these protocols, the main reason I started to work in this was that I saw that many industries are not using these protocols, and we don't know that yet. What are these? And so my motivation was to motivate to the industries that we should now start working and using these protocols, because these are consensus protocols, and they allow, especially in the cloud environment, it's important to know when outages happen. So most of the time when some outage happen, it's due to we don't know the reason behind it. So they make more sense to be used in those environments. So I'm seeing that now it's being adopted by the industries, and the first protocol, that is the PBFT, practical BFT protocol, is being implemented by the companies. But earlier, before that, it was only Paxos, limited to Paxos, I would say. So yeah, I was working, but my background has always been in distributed systems, in cloud computing, and the fault tolerance, you can say, and also now it's growing to IoT and AI, and learning every day, and containers for sure.
Okay, that's cool. Thinking about IoT, I mean, it's always in the title of today's evening, right? So we have to deal with heavy data. There's a lot of data load. And I think that's something which is just, I'm very curious about here, how to handle that with all your cloud background. That's probably quite interesting. So
Yes.
take the floor, please, and show us.
Sure, definitely.
Thank
Thanks
you.
for that. So I will share my screen now.
Yeah, happy.
Okay, tell me if you see the screen. Okay, perfect. All right, share that as well. So hi everyone, once again, and I'm Divya Gupta, and I'm working as solutions advisor in IoT Global Division at SAS Institute. So today we will be discussing how we are processing IoT data, which is coming at a very high speed using different analytical solutions, and also running these solutions either at the edge or in the cloud environment, or also in the prem environments, on-prem. So, all right. So before we move into the details how we are doing it, it's first important to understand what Internet of Things is all about. So what we are seeing is that we are having a petabyte scale of data that we need to that we are seeing is getting generated through various edge devices, be it cars or manufacturing equipments or hospital equipments or like medical equipments, you can say. And like every single device that we see around today, around us, is generating some data. Sometimes we are using that data and sometimes we are not using it. So IoT is the ability to capture this data, to monitor this data, to process this data and rapidly generate information, process information, I would say, which is critical for the modern and digital enterprises. And it is important that we have this data being processed so we can have we can derive hidden insights from that. So, and take actionable steps and can make all these devices more intelligent. We can have a feedback loop that can give these edge devices knowledge how they should react in the future.
If I look at your pictures, I think it's probably fair to say it's just increasing, yes? So we are
Yeah,
more
of
and more
course.
touching the world.
Yeah, this image that you see here, it's from CERN. And I visited that, I think last year, and I was working with one of the person there who was in the data acquisition system. And he told me, I visited the facility and I realized that they are generating about like 30, 40 petabytes of data whenever they run experiments. And it is such a huge amount of data that all the industries together cannot generate, So this is like pool, like a universe of data here. So yeah. So yeah, so next is that IoT is not only bringing a fundamental rethinking, but it is forcing the industries and the businesses to rethink how they have been working so far and also operationalize their strategies. And what we need an ecosystem of all these industries so that we can create the right digital infrastructure, and also we can create the right applications that can help us deduce the right values from the data that is being generated. And so far, we are always working with a very traditional type of computing model. So it is also important that we leave that and we move to the way the new style, the new real-time analytics is happening. So we cannot always send everything from edge to the cloud. So IoT is also helping us run analytics at the edge and also at the cloud. So this is also something that is required by the industries in the future, and some are already there. They're running analytics at different levels, at different steps in the whole process. So I will show you more on this in the next slides. And also, this is helping, IoT is helping these businesses expand. And also, these businesses are now investing in different ways. They're investing on like new analytics processes and what they should run, how they should run, so that we can gather more and more insight from the data that is being generated. And we decide what data we need to generate and how it should be generated, from where it should be generated. So we are deciding that, and then we capture it and we derive the insight. So this is like a whole infrastructure that is helping us become more powerful and make our devices powerful. So where is the value? So the value of IoT, I would say, is captured through analytics, and just by simply connecting the devices is not enough. So we need to understand, we need to sense the data first, we integrate it together, aggregate it, and then understand the data, understand what we have aggregated together, derive some insights from that, create reports, create alerts, and at the same time, derive the actions we can take, and then that can be sent back to the devices and this will give intelligence to our devices. So I would say that it is all about this cycle of sense, understand, and then taking an action on that. So what you see is what brings the value to IoT. So what we normally observe, that the value is manifested in three ways. So the first is business efficiency and optimization. What it means is that we continue to do what we are doing, but in better way, faster way, and a cheaper way. So this is important for optimizing and reducing our costs. And also we want to give the customers enhanced experiences and better experiences for the products or the solutions they are using these days. And this definitely involves business remodeling. So they have to think differently, and this will help them create different products. And this needs that they should explore what's happening around. They should explore the new services and to also think what are the new value propositions for them and which differentiates them in the market. So this is what is actually bringing the value from what we are getting from the IoT. And the study from McKinsey says that by 2025, we will have more than, it will bring $11 of trillion dollars of economic impact, which is huge, I would say. So what are the empowering, what is empowering IoT? There are four key technologies that are helping IoT to what IoT is today, what we understand by it. So the first is analytics, streaming analytics. We need to derive the value from the data, and we need to process this data in real time, and we need to understand it and then take actions based on what we learned, what the analytics tells us to do. And then network. It is very important because everything is Internet of Things. So we need internet to connect these things. So a fast internet, a high-speed internet, which has zero latency is very important, that connects all these devices. And because of that, we can have seamless connection between the edge devices to the cloud or to the on-prem infrastructures. Next is data. Of course, we need to understand what is the variety of data that is coming from IoT devices, how much data we are getting, and so we can understand what infrastructure we need to absorb this data, and how we can use this data and run our analytics model on this huge amount of data. So we need to understand this as well, and this is what is also helping us empower the IoT infrastructure. And last but not the least, AI, artificial intelligence. It is basically programming intelligence to our edge devices. So what happens is during the whole cycle, they are learning and processing and also taking actions based on what they are learning in the whole procedure, in the whole cycle. So it is very important to have all four of these, and this helps the IoT grow faster, and it is a connection between all this that is empowering the IoT today.
If we are just looking at the kind of slide you're showing us here, in what field are you working? Are you specialized in something in that area?
I'm working in all except 5G, not into the 5G network, but using it every day.
Okay.
Yeah, but working in streaming analytics, analyzing the data, what is coming and what data we need to generate. So I'm working on that as well, and also using different AI machine learning algorithms because they are integrated already, most of them in our analytics servers and engines. So if something is not there and in the future there will be new, so that can easily be added through different languages. We can have Python, or there are plugins that can be used to use the algorithms that are not currently in there.
Thank you.
So what is AIoT? It is when I would say AI meets Internet of Things. So it becomes artificial intelligence of things. And here what you see is that we have the whole cycle of data discovery and deployment. So during the whole cycle of analytics and the whole cycle of IoT, we can use AI. And so I would define it as that it is an intelligent connection of network of devices that are communicating with each other over a very high-speed network, high-speed internet, and then we are deriving hidden insights from the data that is coming to us from different devices, or sometimes it's also not just the devices, but it is also the databases, some historic data that we are holding, and it could be the data coming not only from the on-prem structure, but also from different various platforms and units. So it's all about collecting that data and finding the real value from there. And of course, by using the real-time analytics, because we want to process it now and use it right away, not wait 10 years to use that. So we need to have real time. So I would say Internet of Things, it is a technology that is helping us reimagine our daily lives, but artificial intelligence is actually the driving force behind the IoT's full potential. So I would state it like this. So this is what in any IoT, AIoT streaming analytics a complete reference architecture would look like. So what we have here is that on the right side, you see that we have model development, model manager, operationalization, design, and testing. So these are used to create your models, to understand what the data is telling you, what the data is all about, and then also manage the models, because you will have hundreds and thousands of edge devices. Each edge device might be running an analytics engine there, analytics server there. So we need to, and it would be running a model in that engine. So we need to understand, we need to have a platform that can manage all the different models that are going and running in the edge devices. And also, if there is an update on the models, how we can send it to the edge devices. So all the model management can be done right from different solutions. And the cloud and the streaming analytics and the edge streaming analytics is what I will be talking about mostly today, that how we are doing the analytics at the cloud and on-prem, of course, and also at the edge, at different edge devices. So the edge devices, by edge devices, I would say I mean at the edge, exactly at the device level and also at the gateways level, because sometimes they are all the edge devices, all the different devices, they are sending the data to a common place which is close to their close to them, and that is called the gateway. And then from the gateway, the data is sent either on-prem or to the cloud. So I will show you how the analytics can happen all three levels. So what we can do is we can train advanced analytical models here. We can deploy them and understand what's happening, and also use multi-phase analysis. So everything is right in the whole AIoT and streaming analytics framework. So there's nothing that can be, if you can always use other components, but this is already a complete package that can be used. So yeah, so these are the highlighted things for today. I will be concentrating more on that. So where are the benefits when we have the AI that enabled IoT? So first is cost reduction. This is what we see, that whenever we have lots of equipments in the companies, in the manufacturing units, they are failing time to time, and the losses that we are seeing is due to their failures. They break down and we don't know when that's going to happen, so it's like untimed breakdown, and that is incurring a lot of losses, like monetary financial losses. And we have seen that about 42% of these outages are happening because of the equipment failure. So it is important that we do predictive maintenance, we do anomaly detections. So this can help us determine the issues ahead of time. And we are using AI and machine learning to help us identify different patterns and different anomalies, and also make predictions based on the historic data and also on the data, on the new data that is we are getting all the time. So we need to understand how we can make all these predictions beforehand. And for example, French power utility EDF group, they saved about $1 million by introducing AI and machine learning and IoT in their infrastructure, in their setup, the way they are running the analytics there. So also, it's important. What it is bringing to us is like boosting the operational efficiency. That is how we are. It's basically about that we are getting so much of data. We are analyzing it, so it is giving us a lot of deep insights into the problems and helping us understand that, and so we can take actions before something happens. So this is helping us become more efficient, and have more productivity, because we are reducing the downtimes here. So by removing the downtimes, we are increasing the productivity, and also there are lots of varieties of tasks that can be automated using these machine learning and AI, and this is improving our efficiency at altogether in the companies, in the enterprises. And it could be not just, I'm talking about the manufacturing, it could be any enterprise, any industry. It could be oil and gas, it could be utilities, it could be cars, and it could be smart cities. Everywhere these benefits are applicable. The next is that it also enables the businesses to offer more models, like more services. And for example, Rolls-Royce, it introduced this IoT-enabled airplane engine maintenance services. So this is helping them to offer more services to their customers. So they might be having the other services as well, but this is something that is helping them to have IoT-based services as well. So this is helping them become better and have more product lines and more services. And then, of course, better analysis of risks, and also how they can manage it, given we are having so many security threats around. And so this helps them to analyze the risks way ahead, and also do a better analysis, so they can have better safety of the people who are working there, better safety of their equipment. And this also helps them reduce, again, their financial costs, because we already know what the risk factors could be, and we can try to eliminate them beforehand. And then we have last is faster innovation cycle, because now we have all these smart analytic solutions, so we can have better and faster innovation life cycles, and then we can have a faster time to market here. So how we leverage artificial intelligence of things. So there are all these different topics that helps us derive the real outcome. So I will go through some of them. And this is not limited to all these, what I have listed here. There are many more here, just due to the space crisis. I could not put everything. So I would say, like, we can have pattern detection. So we can train a model to anticipate what are the patterns of our interest. We can do anomaly detection by SVVD models, and because sometimes we do not register, we are not registering all the anomalies, and they are not always registered. So we have very few of them for training a supervised model, and so this can be used as well. So we have text analytics. So many of these traditional way was to write everything and have like unstructured data style of keeping the data. So there are still a lot of customers who are still having unstructured data. So it is important to get what the text is telling us. So for example, there are warrants, insurances, and consignment claims. There are different things that are still very textual. So it is important to understand what it is saying, and from first is to read them and then analyze what the unstructured data tells us. So finding the hidden insights from there. And then, of course, build stability monitoring models by using forecast approach, or by using temporal dimensions. And then we have computer vision. So this can be used because it's not possible for us to be present everywhere. So we need computer vision to monitor the physical degradations that happens. And so it could be like cable cuts, it could be rusting of the devices, or it could be rusting of the equipments, or it could be there are some scratches on that, so that needs to be taken care of. So sometimes there are lots of wear and tears on these devices. So computer vision can be used, not just devices, but equipments, that things that we have around. So we use computer vision for that. And digital twin is something that we can use to have a simulate the behavior of the complex systems. So this can help us predict and prevent mechanical failures and inefficiencies we can reduce these inefficiencies and also the cost. And these can also reduce the time to value and time to resolve these problems. And also streaming event stream processing. So this is all these together is how we leverage AI in IoT. So just ask me questions if you guys have any questions as well. So I would now talk about the Sas Streaming Analytics. So this is an event stream processing functional architecture, and this is what I'm working on like daily basis. So here you see that on the sensor side, we have the edge devices, and there are lots of devices that are sending the data to the streaming analytics at the edge. So at the edge, I would say is the gateway part. And then from the gateway, the data is coming to the cloud, or it could be a public cloud, private cloud, or on-prem environment. So what cloud native services, because when you are on the cloud, you also get the lots of services that they offer. So you have some benefits there. So that is like if somebody can move, or if the customers can move it, if the enterprises can move to the cloud environment, they get the additional benefits of clouds as well. And so what happens here is that at the sensors, we can have the analytics running right there. Then the analytics can happen at the gateways, and the analytics can happen at your infrastructure, be it cloud or on-prem. And then what you see here are the different products as well, that solutions, I would say, that can help you to create your model. So ESP Studio is used to create your model. Event Stream Manager is used to manage your models, because you will have lots of models in your system, as I was explaining earlier, and you want to manage where exactly this is being deployed, in which truck or in which wind turbine it has gone. So you need to manage them. Like you might have different facilities across the region, and you might have like hundreds of wind turbines running there. So you need to know which wind turbine is running which model, and you want to have orchestrate everything from one portal. So Event Stream Managers allows you to do that. And if tomorrow there's an update, you can do just by using the ESM as well. And the Stream Viewer is the one that is used to visualize. So you can have what the data is coming in my models and how it is being processed and what is the result there. So it helps you create the charts. It helps you plot everything, all the data that is coming through. It gives you the real-time flow of it. So you can have pie charts, graphs, and whatnot. It's all a visual way of understanding it. And you can also see the real time that whenever there is a point where it would raise an alert, so you can see that there as well, that there is a problem happening. And you can create your own dashboards, because if there are multiple users using it, they will have their own accounts and they can create their own dashboards here. So now everything is on Kubernetes as well. So this is another additional benefit, and I will show you what benefits we get there.
That's
so
a good question. Back to the slide you showed here before.
Okay.
Just back. Since we have a lot of people who are just novice to the field of IoT, this is just like, well, okay, this is really a lot of steps, a lot of work, and a lot of analytics and a lot of data, right?
Yeah.
So this will drive me crazy. So since just looking at the data sources, yeah, this obviously keeps a lot of computing, needs a lot or requires a lot of computing power on the other end, right?
Yes.
So, but at some point you need to start to think about what are you actually want to measure, right? You can measure everything, but what do you really want to measure?
Yeah, so for example, it varies. Like if you have, for example, in the trucks or in the cars, in automobiles, you can measure the pressure in your tires. You can measure how all your systems are working in there. There are different temperature sensors. So there are different sensors. They are all the time sending you the data. So beforehand, you will know that. So there will be an edge device running. For example, a car. You can take a car, and then there will be an analytics engine running right there in your card that can tell you that, okay, your pressure is will be reducing in, it has reduced to this much level, and you need to put more pressure in there in the tires. So it is doing these like calculations right there. So for example, in the latest cars in Tesla and BMW and Mercedes, you already have these engines running that are telling you when it's time to change your oil, when it is time to change your, the pressure is reducing, or it's too hot in the car, or when it's too cold outside, and when you should start, it's raining, so you should start cleaning your wiper, or it automatically starts it. So all these, and then you need to understand that if something would fail, these sensors might fail as well. So there are different data that you're collecting there, and it varies from industry to industry. So from cars, you will measure this, and if you are in a medical manufacturing firm where they are pharmaceuticals, for example, so there they would be measuring at what pressure the medicines are getting compressed, the powders are getting compressed, so it becomes a tablet. So at how they, for creating the capsules, what is the pressure that they take 2 packets and put the medicine inside and pack it. So how that is done, if it should not be put a lot of pressure. So there are machineries there. Since everything is automated, they need to understand what can fail at what time. And if the temperature is maintained, if the pressure is maintained, and if like all these different parameters you can measure there. And like similarly for like wind turbines, you want to know what is the speed, what is the humidity there, what are the temperature there. So yeah, it really depends from your industry and what's the use case there.
Okay.
So this is our Kubernetes high-level architecture. So what you see is maybe people here are aware of Kubernetes and maybe some are not. So I would just quickly tell you that Kubernetes, it just allows us to, it creates it's an orchestration platform that allows us to create all these run container pods, and it manages the pods that are running in the Kubernetes cluster. Whenever something fails, it restarts that for you. So it gives you more of automated control over the things that are running in the cluster. And so here what you see is that we have the Sas ESP operator. So this is the heart of our architecture here. So it is based on Kubernetes operator APIs, and it is the one that is now responsible to orchestrate all the ESP server pods that are running in the system. So ESP operator is also communicating with the different web applications that I was explaining earlier, the Studio, ESM, and the Stream viewers. So so whenever we want to run a model, or we want to deploy a model in a edge device or in a server, for example, if it is on the cloud environment right now, this is the case of cloud environment. So if you want to have some servers running, Studio is used to test it, and so it will send the instruction to the operator, and the operator will be the one that will start your ESP server there. And this ESP server will be running the model that is our analytical model, and this model can then be sent to the gateways, to the edge devices, where it would be running as well. So this is the case when we have the analytics happening at the cloud level. And here you can also have, like, we have different, we want to have some data that is coming probably from Kafka, for example, from a message bus, and we want to have the data flown, it is coming to the Kafka, and then the ESP server pods, they can have, they can retrieve that data from the Kafka as well, and they can write it back as well when they are generating this data. And then there is a database. So database, we always want to store some of the data, and then some of the data that we want to process, there will be some data that is used for lookup, some data that is already there, and we want to check, for example, in a telecom industry, there will be some data, customer data will be there. We want to keep that and want to access it over time when we are running some. I will show you that example of telecom, it reminded me. And so this whole architecture is running in the cloud premises and a cloud environment, and also it can be on the on-prem as well. So what you see here, that there's an access management as well. So you can have multi-tenancy, and you can have multi-user facility here. So you're not restricted to use UAA, which is the user account and authorization. So there could be other solutions as well here. So this is what we used, and this is by the Cloud Foundry. And so it tells you that there are a lot of open sources that we can integrate here. So it's not limited to one like only SaaS products. We can always integrate it with the open sources as well. And also the programming and the model, everything can use Python, C, and SAS code, DS2. So we also support a lot of other languages as well. So this is like very high level, but now I will take you to a level where we'll be probably easier. So this is like when it is running in an Azure environment. So we have like the ESP running with all its components, and we also have like other analytics tools that could be running as well. And then this is all happening when we have the edge devices. And so what happens is that we have the edge devices. So Azure IoT Edge is providing us a platform that helps us connect the edge devices with the cloud. So this is very important in today's environment, because we have lots of edge devices and lots of analytics is happening right there, but sometimes it's not possible to run everything there because it could be just some sensor information and there is no way to process it right there. So we need to send it. So we need to send this data over the network, and this Azure IoT Edge is helping us connect any type of device to the cloud environment. And then it is creating a connection layer, or like providing a network kind of level that allows us to have any number of edge devices send the data to the cloud. So here we have the IoT Edge, and that is helping us bring the data to the Azure IoT Hub. And through that, we have the data going through the event hub, or it could be a Kafka, or it could be any other message bus. But this allows us to get the data, and then we can have auto-scaling ESP servers that are running, and they are running the analytical models right there. So this all is helping us do all the processing real time. And because of the high-speed network, the latency has reduced to like in I would say milliseconds, less than that, in fact. You don't even feel that there is a latency now. It's like, that's why it's called real time. And so again, we have connections with them because we want to have access through the applications. There will be some application-based solutions as well, so we can make actions. So for example, if there is some alerts happening, so we can have the indications sent directly to the person, the technicians who are supposed to handle the alerts, to handle that, okay, what's gone wrong and what is the action. So it can give alert on the different mobile applications and your web browser. So you can use different applications to access everything that is running in the cluster. So when you are designing your model, you use the studio. So the studio as well is accessible from a web browser. So you do everything from the internet, and everything else is also running in your cloud environment. So I will now tell you what benefits we have got by moving it to the cloud. So the cloud environment, it is providing us the elasticity, that is auto-scaling ability. So whenever we need more resources of CPU or memory, then the cloud environment can auto-scale the things for you, and it can elastically scale up and down. It also facilitates implementation of flexible and scalable business models, because of course there will be cases when everything needs to be scaled up. There is a lot of data that is coming in, resources to meet the capacity for that much amount of data. We need to also increase our resources there. So it also gives you the flexibility, and it gives you the flexibility on the choice of platform. It gives you the flexibility on the choice of infrastructure, storage, and the computing resources you want to use there. And it has this geo-distributed data centers that can have 24/7 access from anywhere. So we have this cloud to edge connectivity that I was talking about. It gives us that as well, and it can handle connection failures. So if there is a problem in the system and something goes down, it can provide auto recovery and high availability. So you do not lose anything there. And then it also performance, it gives you guarantees on high performance. So from also automation and operation. So these are the benefits that cloud is helping enabling IoT there. And so what it gives you is gives the right analytics applications that can be used for integration and also for data compliance and security, and also reduce the cost, and it is more cost efficient. So you pay for what you use. So basically, all the cloud platforms, I would say, are, when you start working on them, they are very easy to understand because they all use the same sort of terminology there. And so once you are starting on one, it's easy for you to also work on the others as well, because the naming and the what they are used for is kind of very similar, and it's very easy to understand. So there are the different features with what we have got with Kubernetes by moving ESP to Kubernetes. So we have the streaming data, we have got the scalability and the reliability, and also the ways to do the governance there. And so it will help us to have monitoring and updates and deployments and automation. Everything can be done from the streaming framework. And also the whole analytics framework is very easy to use. It's very modern. You hardly have to write any code there, and it's all button click approach, and all language supports it has, and it can be used to not all, but yeah, a few language support, and also open source support. So if you have anything that is that you want to integrate or want to bring it, you can have that as well.
Give you a test for a second, because also we have some kind of connectivity issues, obviously. Can you just switch off your video for a second and turn it on again?
Sure.
At some point, it just got frozen. We were able to hear you, but was not the problem. It was just you got lost.
Okay.
You got lost.
Hello?
Yeah, we can hear you.
You can hear me? Okay, so
we can hear you, but you can't see the video. Can you? We can see the screen, but I can't see you. You personally. Can you just turn off the video for a second and come back?
Yes, sure, I can do that.
Or stop screen sharing for a moment, so you can come back.
Yeah.
It would be lovely just to see you. At mine, it's nice to hear your voice, so it's perfect.
Yeah, I'm just trying to stop share.
Yeah, stop share for a second now. Just retry to connect again.
Yeah, just taking long to stop the sharing.
Yeah. Yeah, I think we got your machine just busy with too much IoT stuff, right? So this is just how it works. Are you still here? Okay, guys, just a short break. As you can see, let's wait for her to return. But I think it would be better just to see her and just not only to listen to the voice, which is beautiful, to hear the stories. But of course, it's just nice to see a face. Oh, maybe she got completely lost and the computer broke down. That would be awesome. Well, do you have already questions regarding the IoT stuff you heard? Just you can turn to the Q&A section and ask the questions. I will have a look at it. And you can also ask the questions during the presentation. Now we are just waiting for her to return. And hopefully she will in a second. I guess the computer crashed. Yeah, probably looks like. Yeah, Justin, you have been asking if I'm going to start IoT and bridge engineering. Sorry for that. No, unfortunately not. I think what I like about the idea of IoT is, and I think that is part of what Divya has been showing already, is that it is a huge opportunity from a job perspective as well. You know, with so much IoT coming up, we need a lot of people who are just trained and working with it and are capable of just doing that kind of kind of stuff. Hey, back, Tivia.
Hi. Yeah, I'm sorry. It just dropped me out of the Zoom. The whole Zoom got frozen. So yeah, I had to kill it and restart the process.
Yeah,
All
no
right.
problem.
So
We
okay.
have just discussing one thing I just saw from the slides you showed. That
Mhm,
was the market development, right? The thing I just mentioned before, it just came back again. Was
mhm.
but I think this is a huge opportunity from a job perspective, because looking at what kind of skill sets you might need to be able to work with IoT, I
Mhm.
think it's a pretty much broad range, right?
Yeah.
Kian's asking a question already. Maybe we can answer that. What are the legal implications to keep in mind if one decides to use IoT? Privacy? What else? Can you list them? Do you have an idea? Just checklist, something like that? Would you suggest to your
Not really.
clients? Not really.
There's a big list of things that we need to take care of, privacy and security and the risks around that. And we have a special team that handles all this. So I'm not usually working on this part. What are the risks and things there? Because it could be risks at different levels. There could be risks at how the data is coming through and what are the security measures that we are taking care at that time because of the GDPR and other things that are there. So there is a whole team for that does all these evaluations and checks before the data comes in and out, before this whole communication happens. So yeah.
I think that's just a good point. So you're just about to start to talk about the use cases. I'm really looking
Mhm.
for use case industries. It's perfect. But coming back to what you just mentioned, so what kind of teams are you usually working with? You said a legal team, obviously, or a risk team.
There is this a risk analysis team, and there are other colleagues of mine that are working on this. That how the data is being consumed,
Yeah,
and if, like for example, in Europe, GDPR is a big thing, so we cannot capture the like both faces of anybody, but we still want to have some sort of computer vision there. We want to monitor who is coming in and out. So there was a use case where we want to see how many people are entering in a building, but we cannot capture their faces or anything. So they were working on this. We follow these rules and regulations. So
yeah.
we had colleagues who were helping us determine that, okay, if we are doing this correctly or not, because there will be images and the images will be blurred, and we just identify the person came in and out. So we just know that there's somebody joined the building and somebody left the building. So and like with the contact tracing, for example, in different, it's being implemented in different hospitals that I will be talking about. So there we do not use any computer vision, but if there is a scenario of a computer vision, then it really, we have to see what are the, we go, we follow the, we are always security compliant, all these rules and regulations compliant. So we have colleagues who are helping us with this to stay
Yeah.
compliant.
So you're just going to talk about the tracing app later on, as you said, or tracing as a subject. If you think about the process model of developing IoT solutions,
Mhm.
uh, so there's probably an ideation phase where just try to figure out what kind of things could be measured, could be done. And so is it part of a process that you actually ask those kind of questions like risks and privacy issues from
Mhm.
the beginning? Is it part of a design architecture of a process?
It's not part of the design, but it is part of understanding that what we should not do when we are creating the models. Like when we are running our, it's totally outside of creating a model. And this is something that is just because when you are using it, it also depends on the industry that we are working with. And the privacy part is not we actually we do not really work on that a lot because it's something that is outside my scope, I would say, and of how this thing is handled. But during the analytics model, we just know that this is how we get the data and this is how we process it.
Mhm.
So yeah, like for example, if there is an image data, if we have connected a camera and we are receiving the images, it's the frames that we are receiving. So there we have to understand how the data is being captured. So it is the camera that needs to be tuned to get the right and to transfer the right information, and not us to remove the faces. For example, if we are tracking somebody who is coming in and out of the building. So it's the camera needs to remove probably. So they have to, this is something that has to be done there before it really goes here.
Okay, so looking forward to use cases.
Sure. Let me. All right.
Yeah, we can see the screen again.
Cool. Okay, so the first use case is, in fact, contact tracing. So here, when you, it's full of that now because of the COVID, and we want to be safe and healthy and not get COVID. So, but we still want to keep everything running, and we keep moving in and out of different, we want to go visit the groceries, we want to go for the health cases, we want to go pharmacies, we want to enjoy our lives in general, want to go out. So we have to maintain some distance restrictions that we are being told, and also use the mask and stuff. So there is a lot of help from the AI and machine learning that's helping us in contact tracing now. So these are the different newspaper, or I would say web-based newspaper that I was going through, and they provided how AI is helping us to have the contact tracing, in fact. So how we can use AI, how AI technologies are helping us to improve the way we are doing contact tracing. Just a second, I need to move this photos here. Okay. So this is a small video by Council of Europe, and I really like this video. And it tells you like how AI is helping in controlling COVID by contact tracing, so how it is being implemented there. So just like a 1 minute video. Yeah, so I really like this video, and how it tells us what we are doing. Maybe I can just stop my video in case it's again creating a problem. Yeah, this photo is also nice.
I think I would, it looks like it's a perfect leisure time, but maybe I'll just do it differently. I stop my video and you keep yours.
Okay. So so this is a link here at the bottom, and I would recommend everybody to go through it, because it provides a lot of things what we are doing in Europe, and how in Europe we are having the AI being used at different places. It has lots of use cases, and recently they are adding a lot of information about the AI in healthcare, AI in different industries, and AI in COVID as well. So there are lots of interesting articles there, and I think they also have articles from other countries as well, apart from Europe. So this is very interesting link, and if you want to stay updated what we are doing in Europe, like from the government perspective, it's a good place. So let's switch to the use case that I wanted to talk about. So we are working with a partner. It's called Intelligent Locations, and we together are building solution of analytics for COVID tracing, contact tracing, and together we are trying to find out that how we can trace back the people who are infected, and how we can minimize this. So we are here again, we are analyzing a lot of people who are entering the hospital. So this solution is implemented in lots of hospitals, and we are having beacon devices and gateways that are sending the information in the cloud environment. So we started with we started with assets tracking and patient tracking, but with the COVID, we also started working on the contact tracing. But then it can also be, the solution will also be not the same solution, but we are also working on solutions, use cases that will be for staff management, for asset management, because most of the time in hospitals, the nurses and the doctors and the staff, they don't know where exactly the assets are. 40% of the time, the assets are lost. They don't know where it is. So we are not using everything that we have in the hospital. So it is important to know where the assets are. And so whenever there's a need, they can be reached quickly. And so everything will be, the information will be real time, and all the staff will have where the assets are. So I will now go into the contact tracing, how we are doing that. So basically, how it is being implemented is that each room will have a gateway that is sending the data from the devices, from the beacon devices. So all the staff members will be holding beacon devices with them, and the gateway will always monitor the movement of the staff. So when they go from one room to another and like that, so each gateway, they could be, the number of gateways really depend on how big the hospital is, what is the strength of the gateways, if they can capture the beacons or not. And here, for example, the red guy, he would, if he's infected and he moves to another room, if the distance is not kept like greater than 1 meter, then it is possible that the person would infect the other guy, and the other guy, when goes to another room, can infect others. It monitors that what was the distance that was kept between the staff, and when they're interacting with other staff members, or when they're interacting with the people that they are coming to the hospital. So this is how we are tracing. We are tracing when they leave the room, when they enter a room, and how much. So we know the coordinates of each person. So we know how far they are from each other. So we know their location. So based on all this, we are trying to understand that if they can transmit the virus to others or not. So everything is wireless, the whole data transfer from the beacons to the gateways to the cloud platform, it's all wireless. So this is a very simple, very high level architecture for this particular use case. So we have, again, our ESP components running in this cloud environment, and we are using AWS here. And everything is coming to the Kafka message bus. And then there's some data that we are storing in the database. And there is, because every time we want to keep the events, some of the events for later evaluation as well. So it is integrated with the database as well. And so the hospital devices or the assets, I would say, or the staff members, the way they are moving in the hospital, all the information is being sent to the AWS platform here.
I'm
So
just smiling a little because I read theft detection. So
yes.
anyone just stealing patients?
Yeah, theft detection of assets.
Of assets, yeah, sure.
Yes, so because sometimes you never know, there might be people who just come and they take the stethoscopes, they see a doctor is not taking care, they just takes it away. So to avoid the theft, because since there will be a monitoring device for each asset as well, so you can know if the asset is there in the hospital premises or it has already left, so you can track your assets there. So
tracking assets, so you probably have kind of chip, something like that. Which can be tracked, right? Okay.
Yes, there is a beacon device that sits on these assets.
Okay. got
Yeah,
it.
that can tell you where the asset is at this point, in which room, what is its location. It can track everything there.
Interesting. Okay.
Yeah. So if, for example, if an asset is stolen, then it's obvious that there was a theft that happened in the premises. So the next is in the manufacturing, and here what we are doing is that we are trying to detect the anomalies and how the machines are behaving, if they are working correctly or not, or if there is a problem, there are some glitches there, or if there is some things that we can predict. We can do a predictive maintenance here. If something is going bad, we can understand it in beforehand or before time that this particular machine needs to be fixed, or there's some skewing happening here. And this would, of course, help improving the productivity and also the quality of what is being generated, being produced by the company. So there are different use cases for manufacturing as well. And currently I'm working with two use cases, which is predictive maintenance and detecting anomalies. So here we are heavily using AI and machine learning. So this is again a simple, very high level architecture. So we have different edge devices here. So these are the different machines that have different sensors, and they are sending the data to the gateways. So they individually, they are not running any analytics, but the gateways are having the analytics engine running there. So the models are right at the gateways. So, and the whole orchestration is happening from the cloud. So the cloud can run analytics models, but it is, in this case, it is not, and everything is being done in the gateways. So the devices are sending the data in the facility gateways, and the analytics engine is performing the operations and deriving the actions, what needs to be done. For example, if something is failing, they found an anomaly there. So then in that case, the actions, the alerts can be sent to the cloud or to the technician who is managing all that. So there are different ways to understand the alerts, but the processing is all handled in the gateways. So this is helping us reduce, helping the manufacturing enterprise reduce the downtimes of the different equipments that they have, different machineries that they have. And because of this, there are less downtimes or like no downtimes. This is keeping them continuously increase the yield that they have, and not just increase, but to have at least consistent, because they know how much their machines can produce. And also this helps them to have this closed loop feedback, because with what is running in the whole system, and how with optimized basically with the optimized models that we are running in the gateway. So it's a complete closed loop feedback, because if there is we can also send some messages or some how the devices should behave if you want to start and stop from there. So that can also be done through that.
Do you have an idea of the amount of data which is just running through that models?
For this particular use case?
Yeah, for predictive maintenance, for this use case, exactly.
I think it's in about over a million that is being processed. And so so what we are achieving as a throughput is about like a millions of events being processed per second.
Per second.
So per second, yeah.
So I mean, just thinking about it, I mean, it's predictive maintenance, right? So there should be some outcome in the end after a lot of maths and calculations.
Yes.
How fast is actually the response time? So from having a change in the data input to having a result which says you have to do something.
Yeah, it's like you have a good amount of time between you actually take the action that something is going to go wrong, because it is already analyzing. Like, for example, as I understand, if there is an anomaly that has happened, if there is a then it's not that you have like split second time to take the action. So it just gives you an alert that there is a possibility that something will go wrong in the near future, or in like some hours time, then you have the enough to fix the problem.
Kian, you had another question regarding the equipment. Would you like to speak yourself?
Yes, thank you. Appreciate that. Yeah, I was asking whether it's possible to add sensors to any equipment, like old ones, or should, if I'm thinking about myself, should I buy new IoT devices in order to use IoT?
No, you don't really have to. Like if your device is already generating some data, it has sensors that we can, register or we can use, then it's good enough. We do not have to buy different devices that are IoT enabled. We just need devices that they can communicate over internet.
Okay, thanks.
Thank you, Kian, for the question.
So the next one is for the telecom use case, and here there are different use cases again. So we have optimizing the network operations and providing solutions, or providing providing the data plans, or because they are subscribers, they are customers for telecom. So you can provide some customer benefits, and you can give them some offers that if your usage is above this much for this particular month, then we give you a customized offer. So here you can use again analytics to help you to find or create these offers for your customers, so that they are more satisfied and they stick to your services. And again, with the asset management and monitoring, because even in the telecom, there are huge towers, and they are also running some cooling systems there. And so this is an asset. So we need to understand if they're running fine or not. So we need to analyze their working as well. So again, it brings in the predictive maintenance and anomalies again here. So so what we understand is that different use cases, in fact, nowadays, all the use cases, they somehow have to have AI part there. So this is making everything more intelligent, and this is also bringing much more power to how the IoT is running and working these days. So here again, the use case is the customized offers. So again, we have the ESPs, which is running here, and the data from the mobiles, like if somebody recharges a phone or recharges their data plan, the data messages send directly to the edge devices, and they know what to, sorry, not the edge devices, directly to the cloud. And then based on their consumption, we are able to create offers for them. So in this particular use case, it was they had about millions, more than millions, like I don't even have the number how much data or how many customers they have, but it's a huge lookup that they need to do, because every time what the solution was that everything was stored in the Aerospike databases. All the information about the customers was stored there. So whenever a customer is doing, recharging or using a data or adding data to their plans, so this is an event. So they need to know which customer did this and what is the new offer that we should give. So there's a huge amount of data that needs to be traversed and searched through to find that particular customer, and to understand what should be done with this. So based on this, it was easier. We were storing everything in the Aerospike databases, and the ESP models, the analytical models that were running in the ESP servers, were able to connect and access this Aerospike databases, and it was doing also the aggregations. And the aggregation is over a large amount of data, because it is possible that the person is a large amount of data and for a long period of data. So for example, it could be the aggregation over last 6 months. It depends on the offer that the company wants to provide. They want to give an offer if somebody used or somebody recharged for like 50 euros for the last 6 months. So it could be that the person is recharging €1 every time. So it really depends. So sometimes it will be for over an year. So the amount of aggregation retention period was very high. So and everything needs to be done in the analytics model. And here we were taking using Aerospike to do the lookup and also do the aggregation. So because of this, all the ESP models were running stateless, and this was like a very good, I would say, um, I think it was very important that whenever a server would fail, then we can come back to the right to the same point where it failed. Of course, Kubernetes is helping us there to bring back the failed servers back to the normal processing the way they were doing. They restarted in like within seconds, and but the Aerospike was used for maintaining the states. It was used for maintaining doing the aggregations and also for the recovery whenever something would fail. So because of this, we were not having any data losses, and because here every event matters, and there will be use cases where you cannot like you cannot drop any event, and there will be use cases where, for example, in machine in manufacturing, if like for a few seconds, if some data is lost, you will not really care about it. And so there are some mission critical applications where you really care about every single event because it really matters. So this was one of the use cases where every event is valuable. And so we have to have strictly zero data losses and zero duplications as well. So everything was done through the modeling here. So the analytic model was able to handle that all. So reaching to the end of the slides actually. And here, so I would again rephrase that IoT, AI, and analytics, that is what artificial intelligence of things is. And again, these two articles are very interesting and it really talks about like how and like how AI is helping IoT and what happens when AI meets IoT. So it's very interesting to read, go through this. And I think Stephen would share all the slides, the whole slides with you, and the links will be available. So you can go through them.
Okay. Just since you mentioned it, as always, we will have a recording of the day available on YouTube. And this PDF file will also be part of a YouTube page. So we will find everything DVI has been showing before just as downloads from YouTube. Thanks for mentioning it.
Yeah, thank you. And so I would just say that data without analytics has no value, and analytics without data is not possible. So this is something I would say here. And these are the different machine learning and AI algorithms that we have. And this list is not exhaustive. There are many more. And if something is missing, that can always be used there. So it's very powerful in that sense. And again, it's not only limited to the 3 industries I was talking about. It's applicable to all these industries and many more. And it's just and even in these industries, there are different use cases where we can apply AIoT. And just in case, if you really want to use the ESP event stream processing, then you can just have a 30 days free trial. And it's very interesting to use that and try it out, because also you get the full support here. And the community is very strong and very helpful here. And the developers.sas.com is very interesting, because for even a slightest thing, there is an article how it can be done, and there are people who are there to support, for example, how to read timestamps, so even for a simplest thing, you can have some help. So these are the different references of the things that I was talking about today, and what's happening, how the ESP is working with Kubernetes, and how we are integrating, how it is being deployed in cloud environment and on-prem environment. So there are different documentations and videos that you can refer to, and have some, if you want to use them, of course, all the products at SAS can be used for free trials for a few days. And this is important link, because it talks about, it has lots of resources here that gives you more idea about what are the different AI applications and AIoT applications and customer stories. So it could be nice. So thank you. And if you still have questions, let's take it.
Thank you, Divya, for just that very in-depth presentation of IoT. Just a question from my side. What do you think, if you just look overall what you have been showing us now today, what would you say, what are the key challenges someone has to face when doing IoT and artificial intelligence?
Yeah, the first challenge is like understanding what the data is and what they want to do with that data and what is the problem that they are trying to solve. And sometimes it happens that we know what is the challenge here, what we want to do, but then we kind of struggle actually creating and finding and right analytics tools and right platform. So it is important to understand the problem and then find the right solutions. And that's why I mentioned that it is very important to have an ecosystem where we know that these are the analytic solutions that are available, we understand them, and then we choose the best one that fits in our need and helps us with our use case.
What are, from your expertise and experience, the typical failures in starting IoT models and analytics?
Failures, I would say I haven't had one yet, so I cannot really. They always have been successful with all the customers I've been working with and different use cases. So they were not like really anything that was that failed, in fact, because since it's a need now, and we have to process things. So of course, and there's a lot of data, not of just data, but there's a lot of information around. So whenever a company or a customer approaches us, they already have a background of what sort of problems they are dealing with, and so they are with us to find an answer and to find the right to create the right model, the analytical model, and understand that what is like which even like sometimes have been situations that which algorithm would fit in well here, which machine learning, how I should do that, what should be my how I should detect or create patterns here. So there could be like very small things as well, but failure wise, I don't think so. I have had any so far.
Lucky woman.
Yeah.
So looking at all the industries you just mentioned for the use cases here, what's the level of knowledge on the industry side? Is there still a lot of knowledge transfer in projects, or has it increased already a lot?
You mean for myself or in general?
I mean, from a business perspective, from a professional perspective, you're just far ahead from the things,
Yeah.
right? You're doing it just on a daily routine.
Mm-hmm.
But of course, many companies have just started beginning with things. And I was just curious to understand, but what's your experience here? How educated is the industry already using IoT?
Um, if you talk about like how much I'm learning from working in different industries, because I can work with any industry and with any use case they're having. And so I'm learning a lot because just before we start to provide them a solution, it's important to understand what the problem we are solving with them. So it's important to understand the industry, not like to a very deep level, but to a minimum level that we can help them. So I'm trying to understand what's going on there and how they want to use uh, what they want to do with the use case. Like, for example, there was this customer, they were working with the wind turbine. So before that, I had zero clue how the wind turbines are really functioning, what are the different sensors that are being used and how they're being used. But after understanding and working with them, I understood, okay, this is how the whole process is. And then I was able to help them better. And it's similarly, there was a use case with pressure sensors. It was in the truck manufacturing company. So there I understood that, okay, this is how everything, all the sensors and yeah. So it's important to understand a little bit of that to provide if there's a new company that is coming into this, for example, if there is a new manufacturing unit that is starting their business, so maybe they first will have to understand what are the different things that they can measure and what they want to do with that, and what is their business outcome, what is their business use case there, and what is their strategy, what is their operational, targets, like what is their business line. So they need to understand that, and based on that we can help them. And sometimes we also, when we are working with some customers and they are new, and in that case we also help them to have some new value propositions, what we can do beyond this. So
okay, thank you very much, Divya, again, for just giving us all that insights and spending your evening time. Yeah,
it's okay. It's
just
good.
private time here. Thanks again, everyone, for who has just joined, and thank you for just being here. I haven't announced it yet, but we will have another meetup on the 18th of February, more about biochemistry and AI. Looking forward to see you all again. So thanks, Divya, for taking
Thanks
the
to
time
you.
to be part of it.
It was great today. Thank
Fantastic.
you.
So have a good night, good day, whatever time it is, and goodbye to next time.
Goodbye. See you later next time.